Okay, here's the helper video for the integration packet. So first of all, I've just put in a couple of the answers for the first page. So -4 x to the 6th plus c for number 1, and for number 7, -1 over x to the 4th plus c, or you could write it as -x to the -4th plus c. And on the quiz, if I ask you to write the answer with no negative exponents, you should be able to do that. Okay, so there it is. Page 2, I've put in again a couple of answers. So number 11, here's the answer number 11, and number 15, here's the answer to number 15. So my 3rd and 4th period classes, I think most people were able to get these done in class, but I know for Mr. Myers' 6th period class, you did not get a chance to do these with me, so I'm going to go ahead and do one more. Let's do number 13. Does that look like a good one? Actually, let me go ahead and do number 16. I like the ones with the square root. So even though Mr. Myers' class, you did not have to do the even-numbered problems, let's go ahead and do this one together. So first thing is, whenever I have a constant, I like to move it to the side. So I'm going to write -5/2 times the integral, and then the square root, I want to rewrite that with a fractional exponent, so that's going to be x to the 1/4 dx. So then when I do the antiderivative, I'm going to add 1 to the exponent, so I'm going to have 1/4 plus 1. In order to have a common denominator, that's going to be 1/4 plus 4 over 4. 4 over 4 is the same as 1, and that gives me 5/4. So my new exponent on the x is going to be 5/4. So when I do the antiderivative, I get rid of the s for summation. I get rid of the summation sign, and I'm going to have x to the 5/4. And then I have to multiply by 1 over 5/4. Okay, 1 over 5/4 is just the same as the reciprocal of 5/4. I could do this over here, 1 divided by 5/4, which is 1 times the reciprocal. So instead of writing that big giant mess, if you can just get used to writing times by the reciprocal of the exponent, that's really the easiest way of thinking about it. Just multiply by the reciprocal of the exponent. Now remember, I still have this -5/2, so I'm going to bring that down. And I can go ahead and simplify this. I have 5 over 5, and then 2 goes into 4 twice, so I end up with -2 times x to the 5/4, and since this is an indefinite integral, I'm going to write plus c. So there is my answer. Okay, next page. So I did this again in 3rd or 4th period, and when you see a number, you can go ahead and separate that out. So I rewrote this as the integral of 4 times 1 over x. That's the same as 4 over x. And then there's my dx. So then we need to recognize that when we have 1 over x, that the antiderivative of that is just natural log of x. So I kept my 4, and I like to just separate out my constant to the other side of the integral sign so that I don't worry about taking its antiderivative. So the 1 over x, its antiderivative is natural log of x, and then I keep my 4. And I write plus c. So that's that. So let's go ahead and do one with an e to the x. So what the heck, let's just do, should I do the next one, or is there something more fun on the back? Yeah, no, we'll do one of these. So this one, I have that -7, so again, I like to write it on the outside of the integral symbol, and I write e to the x dx. Well, what is the antiderivative of e to the x? E to the x. Love that one. So easy. And then I keep my -7. And since it's an indefinite integral, I need to write my plus c. And there it is. That's the answer. Okay, next page. This is where they start getting kind of big and messy. So I'm going to do this one again. I did this one in one of my classes. I don't remember which class, but let me go ahead and copy it over again and show it from scratch. Notice they forgot to write dx on the end, so I'm going to go ahead and add the dx. Okay, they tell you what to use for u, but you should be able to figure that out on your own. You should be able to tell that u is the thing that has the highest exponent. So x here has the highest exponent, so that's going to be my u. So if I let u be equal to x squared minus 10x plus 25, then my derivative, du dx, is going to be equal to 2x minus 10. So then I like to look back in my original problem, and do I have that 2x minus 10? It's like, not really, but I kind of do. It's kind of hidden in here. So I can actually factor out, if I factor out a negative 2, I will be left with 2x minus 10, because 2x minus 10 times negative 2 gives me this. So I'm going to actually factor that numerator. So I'm going to factor out negative 2. Negative 2 times 2x gives me negative 4x, and negative 2 times negative 10 gives me the 20. And then in the denominator, I still have my x squared minus 10x plus 25 to the power of 3. See, now I can see that I really do have my derivative of u. So this right here, let's go ahead and do a little color coding. This is going to be my du dx. This is going to be my u. And the negative 2 I can move to the outside of the derivative, the integral symbol. So bring my negative 2 down. This is my du dx, and it's over u to the power of 3. And I still have my dx, but now I can reduce out dx on the bottom, dx on the top. Those go away. And I'm also going to rewrite this on the top. So on the first couple pages, we were practicing that. When you have your variable in the denominator, we want to move it to the numerator before we take the antiderivative. So I still have my negative 2, still have my integral. I'm moving my u to the numerator, which means I need to change it to a negative exponent, and I still have my du. Now I'm ready to integrate this. So when I integrate it, I have my u. I'm going to add 1 to my exponent. So negative 3 plus 1 is negative 2. And I'm going to multiply by the reciprocal of negative 2, which would be negative 1/2. I'm going to bring down my negative 2. I still have my negative 2. I shouldn't put my equal sign down. I ran out of room. Now a negative times negative is a positive. 2 divided by 2 is 1. So I'm just left with u to the negative 2, and I can substitute in for my u, which is x squared minus 10x plus 25 to the negative 2. And since it's an indefinite integral, plus c, so there is my answer. Okay. So this is why I decided to get rid of all the even problems on this page for everybody, all the classes. You only have to do the odds because they take up so much space. All right, so same idea here. The worksheet tells you what to use for u. Find that derivative. If you don't see it here in the numerator, try factoring the numerator so that you can find your du dx. Okay, it should be hiding in here. Okay, so if you need more help with any of these problems, send me an email and I'll see what I can do over the 3-day weekend. Okay, and then the last part of the packet. Oh no, there's actually quite a bit more. Sorry, I thought this was the last part. Okay, again, it looks like I am going to have substitution because that's the title of the page. So I'm going to have substitution here. So again, if you want, only do the odd numbered ones. If you feel like challenging yourself, go ahead and do the even numbered ones as well. So if I look at this, remember to define u. It helps to use the expression that has the higher exponents on x. So that would be x to the 4th. So I believe my u is going to be 10x to the 4th plus 5x cubed. So my derivative, du dx, is going to be 4 times 10 is 40, x to the 3rd plus 3 times 5 is 15, x squared. So notice I do have my x to the 3rd and I do have my x squared, but I don't have 40 and 15. Well, let's see if we can factorize this. 15 goes into 60 5 times. So let's see, what's 5 times 16? What's 5 times 40? So, looks like we might be short a little bit. Let me just make sure I didn't make a mistake. Okay. 15, oh wait, I'm sorry. 15 doesn't go into 65 times. It only goes in 4 times. Phew, okay, it does work. I'm starting to panic there. All right, so we can rewrite this numerator. We can rewrite it as 4 times 40 x cubed. 4 times 4 is 16, so 4 times 40 is 160, plus 4 times 15 x squared. That's the same as 160x cubed plus 60x squared. And then I still, on the denominator, I have my 10x to the 4th plus 5x cubed. So now I'm going to rewrite it. I'm going to rewrite my integral in terms of u. So the top is 4 times du dx, and the denominator is just u. I still have my dx. The dx's are going to cancel out. I'm going to move my 4 to the outside of the integral, so I have 4 integral. I have u on the bottom. I don't like that, so I'm going to move it to the top, so I get u to the negative 1 du. And then, hey, wait a minute, u to the negative 1, that's one of those special integrals. Okay, so that's the same as 1 over u, which I had over here when I moved the 4 out of the way, 1 over u. That's the natural log. So on this one, the answer is going to be, I keep my 4. When I integrate u to the negative 1, I get natural log of u plus c. And then if I go ahead and substitute back in, I get natural log of, what was my u? There it is, 10x to the 4th plus 5x cubed, close parentheses, plus c. Sorry, I ran out of room there. Plus c. Okay? Do make sure that when you put in the value for u, that you put it in parentheses. That way we know we're taking the natural log of all of this. Okay, so that is what we're doing here. A lot of that, some of them pretty challenging. Okay, so good luck with that. And then the next one, we've got, we're going to have to actually evaluate these. So I'm looking at this, and I'm looking at my x's, and I have x squared here, and I have x squared here. I'm not going to be able to use substitution on this. I cannot use substitution on this because clearly x squared is not the derivative of x squared. So this is not going to be substitution. So I am going to have to simplify this and use my power rule, where I just add to the exponent. So I'm gonna simplify this right now. So I can rewrite this as my integral from 2 to 4, as I can put the numerator in parentheses, and I'm going to bring up my denominator, 3x squared, and when I do that, I have to change it to a negative 1 on the exponent. Okay, so then I need to distribute that in here, so I'm going to have inside my parentheses, so 2 to the 4th, I have negative x squared plus 9, and this is going to become times 3 to the negative 1, x to the negative 2. Actually, now that I think about it, you know what? I changed my mind. I'm not going to move the 3. I'm going to move the 3 out to the side, because this is just times by 3. I can actually move that out and make that a 1/3. Okay, right here, since it's just being times by the denominator, I can scratch it out there and make it a 1/3, which means I can move it out here, which means I can ignore it. So I'm going to ignore it. I don't need that hanging out there. That's just making it more complicated. So I'm going to move it out to the side. Okay, so I now have x to the negative 2. So all I've had to do then is move my x squared up to the top, x to the negative 2. Now I can distribute this because it's multiplication, and I'm distributing across addition, so I'm allowed to do that. So I still have my 1/3, still going from 2 to 4, and I'm going to have negative x squared times x to the negative 2. So I'm going to add the exponents. 2 plus negative 2 is 0, so I have negative x to the 0, and then I have plus 9 times x to the negative 2. And lo and behold, what is x to the 0? That's just 1. So I've still have my 1/3, 2, 4, and this would end up being negative 1 plus 9 times x to the negative 2. And let's forgot to write my dx before. Let's put it over there. Okay, so now I'm ready to take the antiderivative. I'm going to do it in parts. So actually, I think I will split this up again. Wow, these are huge problems. So 1/3, 2 to 4 of negative 1 dx. Since this is now an addition problem, I can write it as two problems. And 1/3, 2, 4 of 9x to the negative 2 dx. Holy cow, I need to learn how to write smaller. Okay, I need some scratch paper. These are huge. This is good. All right, so this one right here, when I have a constant, I just put an x next to it, so this becomes negative 1x, and I still have my times by 1/3. And I'm going to be evaluating that from 2 to 4. Plus this one, I'm going to, I can move my 9 out here. 9 times 1/3 is 3. So I'm going to have 3, and then x, I'm going to add 1 to that. Let's give me a little more space here, sorry. So negative 2 plus 1 is negative 1. And I need to multiply by the reciprocal of that. The reciprocal of negative 1 is negative 1. And I'm going to evaluate that from 2 to 4. So over here, if I go ahead, 1/3 times negative 1 is negative 1/3, and I'm going to multiply that by 4, and then I'm going to do negative 1/3. Yeah, that's right. I'm going to do negative 1/3 times 2, and this is this part, the first part. So if I'm doing this, notice I'm substituting in 4 for the x, and then I'm substituting in 2 for the x, and then I need to subtract those two values. So I get negative 4/3. Negative times negative gives me positive, so positive 2/3. And negative 4/3 plus 2/3 is negative 2/3. So there's the first one. And then the second one, I'm going to substitute in 4 for my x. So this is 3 times negative 1 is negative 3 times 4 to the negative 1. And then I'm going to do it again with 2, and I'm going to subtract this. So it's going to be negative 3 times 2 to the negative 1. And now we need to simplify that. This will end up being negative 3 over 4 when I change that to a positive exponent. Negative times negative gives me a positive, so it's going to be positive 3 and 2 to the negative 1. 2 goes to the bottom. Oh, I do not have a common denominator here, so I'm going to have to go ahead and multiply this one by 2. So 2 and 2, so this one is 6/4 plus negative 3/4, which gives me 3/4. So positive 3/4. Holy moly. I think I am going to reduce how many we do of these. These are enormous. So negative 2/3 plus 3/4. To get a common denominator, multiply this one by 3, multiply this one by 4. I get negative 8 over 12 plus 9 over 12, which gives me 1/12. Okay, did I bring the answer key over here? Did I even get it right? So number 1 would equal 1/12. Boy, I really hope that's right. I hope I didn't do all that work for nothing. Let me grab my answer key, which is across the room, of course. Why would I have it handy? I don't know where it is. Okay. Yes, I'm here. I'm waiting for my answer key. Okay, I can't find my answer key right now, so I'm going to take a pause and come back with another video with my answer key, so that we can make sure that we actually got that. I got that one right. All right, sorry. Pause.